Hey everyone, so today we're going to talk about trigonometry. So this is coming off of our lesson about Pythagorean theorem. So trigonometry is going to be useful when we know less information about a right triangle. So first off, we'll talk about what trigonometry is, and then we'll take a look at these couple different trig functions. So what is trigonometry? Well, trigonometry is just the study of triangle measurement. The study of triangle measurement, meaning angles, sides of triangles. We're able to measure sides that we don't know using trigonometry. So sine, cosine, and tangent are going to be our trigonometric ratios, or for short, trig ratios. So we in trig, trigonometry, trigonometric. We just shorten it all to trig, just because we say it so much. It's a little easier just to say trig. So we got sine, cosine, and tangent. So sine is going to be the ratio, the opposite side of a triangle, or opposite side of that angle, and over the hypotenuse. So cosine will be adjacent over hypotenuse, and tangent will be opposite over adjacent. So we'll talk about a way to remember that down here in just a second. But if we're looking at this triangle over here, if I'm looking at angle A, so big A here, this is angle A, I always look through the perspective of this angle. Whatever angle it tells me here, that's where I determine opposite, adjacent, and the hypotenuse stays the same. But the opposite side from A is going to be little a here. So I would say A over the hypotenuse, or the longest side, which is C. So A over C. But if I switch up the angle to B now, well, sine opposite of angle B here is little b. So B over C. Sorry, I should have wrote it like this on that one. A over C and B over C. Let me switch this up a little bit. Kind of like that. A over C, B over C. Okay, so A over C, B over C. Cosine, again, is adjacent, meaning adjacent means next to, or next to. So the angle that's next to, the side that is next to my angle, sorry. So if I'm looking at A here, big A, the side that's next to it, you could say B or C, but C is the hypotenuse. So it would have to be side B here, so B over C. Kind of the same one we got from sine B. Cosine A is the same thing. Well, if we look at cosine B, adjacent to this now is side A over C. And finally, we have tangent, which is opposite over adjacent. So this one no longer deals with the hypotenuse like these two. So opposite and adjacent of A here. So opposite of A is side A, little a. And adjacent to angle A here is side B. So A over B. And now tangent of B here, big B, opposite is little b, over adjacent, which is A. So you can kind of see these two are reciprocals, or they're like flipped, right? And if we go and look over here, cosine B was the same as sine A, and sine B was the same as cosine A. So you're going to see that pattern show up quite a bit. So a way that we can remember all this, because I know sine, cosine, tangent, that can be a lot to remember, but we have a little acronym that we can use to remember it. So we have SO, CA, TOA. SOHCAHTOA, 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 SOHCAHTOA. So that acronym can help you remember sine, cosine, and tangent. And the way that's going to work is, well, SO, S-O-H, that sine equals opposite over hypotenuse. So we can say opposite over hypotenuse. The O stands for opposite, H stands for hypotenuse. Cosine, so CA, cosine is adjacent over hypotenuse. So adjacent over hypotenuse. And that means tangent is opposite over adjacent. So opposite over adjacent. And again, we're going to use these quite a bit throughout this unit. So we'll keep using SOHCAHTOA. Again, this is going to be the kind of the important part of our new unit. So let's take a look at a couple of examples where we actually put some numbers to them, and we can identify the sides or the ratios for sine, cosine, and tangent. In a future lesson, we're going to use this to help us solve for missing parts of our triangle. So let's take a look at our practice. So if we look at number 1 here, number 1, I'm going to do sine of A, sine of C, cosine A, cosine C. So I'm going to do both angles here, both acute angles, to figure out the ratio. So if I'm looking at A here, remember sine is going to be opposite over hypotenuse. So opposite of A is 5 over the hypotenuse, which is the longest side opposite of the right angle. I like to label that because that one's never going to change. So that's the hypotenuse, 13. But now if I switch my sine to angle C here, now opposite is 12. So sine of C is 12 over 13. So it changes depending on the angle that we're looking through the perspective of. So now if we look at A for cosine, cosine is going to be adjacent. Well, adjacent to A is going to be 12, and the hypotenuse is still 13. And if we switch to C here, adjacent to C is 5, and the hypotenuse is still 13. Again, look at the pattern here. Sine A and cosine C are the same, and cosine A and sine C are the same. So now if we take a look at tangent, tangent of A is going to be opposite. So opposite is 5, and adjacent to A is 12. So tangent does not deal with the hypotenuse, just the opposite and adjacent sides. So if we look at C, C is going to be opposite, so 12 over adjacent 5. And kind of like when we looked up at the ratios above, the tangent ones were reciprocals or they were flipped. Again, that pattern is going to stay consistent. So let's take a look at the second one down here. Try to keep the ratios up here so we can kind of refer back to them. So if we're looking at 2, well, we're missing a side here. We're missing the hypotenuse. So if we're missing the hypotenuse here, we can do a little Pythagorean theorem to figure out what that should be. Well, 9 squared plus 12 squared should equal my hypotenuse squared, the side I'm missing. And that's going to be 81 plus 144 equals C squared. And 81 plus 144 is 225 equals C squared. If I take the square root of both sides, I'm going to get 15. So this missing side here is 15. And again, this is the hypotenuse. That's not going to change. So using that, that's going to help me find out all my other ratios. So if I'm looking at W here, W opposite is 12 over 15, 15 being the hypotenuse. And if I switch to X, opposite of X is now 9 over my hypotenuse of 15. Cosine W, so adjacent to W, the side that's next to it, is 9 over the hypotenuse of 15. Again, if we kind of look, those are the same, which means those two should be the same. So let's double check. Well, adjacent to X here is side 12, so that is true. 12 over 15. And finally, for tangent of W, we're going to have, where's W? Opposite, so 12 over the adjacent 9. And over here for X, we're going to have adjacent 12. Opposite is 9 over 12. Again, normally we would reduce these fractions, like this would end up being 4/5. This would be 3/5, 3/5, 4/5. So again, we would reduce those, but just for sake of time, we're just going to practice getting the actual ratio. So again, let's take a look at number 3, which is going to be our last example, and then you guys will practice this a little bit. So let's take a look at 3. Okay, so for 3, we have this missing side here, which would be a leg. So I have to do the Pythagorean theorem, except now I'm trying to find a missing leg. So I'm going to call that A. Well, I don't know what A is, so A squared plus my other leg, which is 16 squared, should equal 34 squared. We'll do a little math here. 16 squared is going to be 256, I'm pretty sure. Yep, 256. So this is A squared plus 256 equals 34 squared, 1,156. If I subtract 256 from both sides, I'm going to get 900. Well, the square root of 900 is going to be 30. So this missing side is 30. Now I know every side, so I can get my ratio. So again, if we go to L, here's angle L. So opposite of L is the side I just found, which is 30, over the hypotenuse of 34. Well, both of those can be divided by 2, so that's going to be 15 over 17. Now if I look at M, opposite of M now is 16 over the hypotenuse of 34. Again, both of those can be divided by 2, which would give me 8 over 17. If we switch over to cosine, adjacent to L now is 16 over 34, which is the same one we just got done with over here, which is 8 over 17 simplified. And cosine of M over here is going to be adjacent is 30 over 34, which again we know simplifies to 15 over 17. And finally, for tangent, opposite of L is going to be 30. Adjacent is going to be 16. Again, we can divide both of those by 2. That'll be 15 over 8. And again, this should be the reciprocal, but let's double check. Opposite is 16 over the adjacent of 30, which again is going to simplify to 8 over 15 now. So again, these are just identifying the trig ratios, being able to pull the numbers themselves from the triangle. Again, a lot of it's going to come down to opposite, adjacent, and hypotenuse. As long as you can identify the hypotenuse, the opposite is going to be directly across from that angle, and adjacent is going to be next to it. So again, we're going to continue practicing this, and then we'll use this stuff to help us find missing sides of triangles. So hopefully you found this useful. Again, if you have any questions, just reach out to me or leave a comment under this video, and I will do my best to get back to you. So I hope this helped, and I'll see you guys on the next one.